Welcome. This is the first MATLAB review. We will basically review how to use MATLAB as a calculator and do some plotting. Let's start. You have 6 problems. The first problem tell you create a row vector x. So row vector is with the following elements 1, 2, 3, 4. So this is 4 elements. So the row vector should have a size of 1 by 4. Let's start. So let's do it one by one. Like let's just create here like the first one, x is equal to e to the power minus 4. That's like the first element. The second element here, like you need about the precedence rule, that would be 4 plus 1 to the power of 1.1 divided by 4. Is this correct or I did a mistake here? Well, I did a mistake here. Why? Because power has precedence over division. So what will happen? It will multiply this term by 1.1, then it will divide everything by 4. But this is not what I want. What I want is this, to raise everything to the power of 1.1 divided by 4. Okay. Time 1.7 divided by 2 times 5.521. Is this correct or I did a mistake here? Again, I did another mistake here. Why? Because division and multiplication, they have the same precedence. So basically, it will divide 1.7 by 2, like this whole term, by 2, and then multiply everything by 5.521. But this is not what I want. What I want is to divide everything by this term. Okay? So you put like a parentheses here. So you see, for this problem, if you got it wrong, you will get no partial credit, because precedence rules, that's something basic. Like you should, main take home from this course would be that you will be able to do the precedence, like get this something like this correct. Because if you cannot do this in MATLAB, you wouldn't be able to do it in Excel, you wouldn't be able to do it in your calculator, and you wouldn't be basically able to do it in any type of numeric computing. Okay, so let's do the third element. So the third element is sine and pi. This is and pi in the MATLAB constant is pi over 4 divided by cosine 35. Is this correct? No, because remember the sine, cosine in MATLAB, that takes the input in radian, but this is given in degree. So one option I have is to convert degree to radian, or just use the right function, which is cosine in degree, cosine d. Okay. The last one here, like you can use the square root function of 5.3 to the power of 5, something like this. Now we can construct our array, so that would be x1, x2, x3, x4. Okay, so that's like some MATLAB basic. You should be by now able to construct an array with 4 elements or any number of elements. Okay. References, of course, so that you get like, so now here is the answer. Okay. Now we will do some matrix division. So the concentration of a network of tank can be represented by the following system of equation. You have 5 equation and 5 unknown. Solve the system of linear equation for like this 5 unknown line. So basically, how to do this? Remember, this is ax is equal to b. That's like what we are solving, and that is would be like we are solving for x. So x, that would be equal to the inverse of a times b. So that's like one way of doing it, or like the easiest way of doing it at MATLAB is like you say x is equal to left division b. So like the left division, that will like do this one, like the inverse of a times b. That's what the left division will do. Okay, so let's just get our matrix A. So like our matrix A, again, we type in like the first equation. So that would be 1, 2, 0, 0, 0. You put semicolon to start a new row. Now we input our second equation. That would be like 0, 3, 0, 0, 0. Our third equation, that would be 0, minus 1, like 1, and 0 for all the other coefficients. The fourth equation, like 0, 10, minus 10. Oh, I did a mistake. That's like 0, 0, 10, minus 10, and 2. And here, that would be like 1, 1, 0, 0, and minus 4. So when you do something like this, you can just run your code to review to make sure you didn't do any typing mistake, because that is a very common mistake. Common mistake is a typing mistake. So here you have like 1 and 2, and all the other coefficients are 0. Here you have like the second coefficient is 3, and all the other coefficients are 0. Here you have in this one, so the third one, you have like 1, 0, minus 1, and 1, and like 0. Here you have, in the third one, you have 2 zeros, 10, minus 10, and 2. And here you have 1 and 1, and like 0 and minus 4. So I think that should be okay. Then the left hand side, that would be like whatever. So the left hand side, like, so here these are your unknowns that has the coefficients. The left hand side, these are like any other number without like a coefficient. Like for example, let me just give you an example. Like if this was here, something like this, I'm just like putting the minus 8 here. That will still be on the right hand side. So let me show you. So here B would be like 10, would be like 0, would be like 16, would be like 0, and here that wouldn't be 0, because here that would be on the right hand side. That would be 8. Okay. And now I solve for X or C or whatever. So my concentrations, that would be like A left division B, which is equivalent, like if you want also to, that's like the inverse of A times B. And if you are in doubt, just like do it. If you don't like your doubt, like whether I use the left hand division or the right hand division, just like do something like this, and you should get like the same answer. I mean, yes, you got like the exact same answer here. Okay, but you don't need both of them. You just need one of them. And then given the concentrations that you calculated, so this is like part B, create a logical array C with logical 1 true for concentration less than or equal 5 milligram. Okay, so C, that would be equal to C less than or equal 5. So if we did something like this, so here we got like for concentration less than or equal. So here we got like these two, and like all the other ones are 0. Okay, so now you don't need, you can hide these things and just show your final answer. That would make the grading easier. And then now, like this is a plotting. Each task counts for 1 point. Input the following function. Use 100 equally spaced value of x in the interval of 0 to 5. Okay, so how to do this? So let's just start like y1, that's equal to exponent of x. Let's maybe put x first. So x, that's like line. We learned that this line is space function. It can from like the interval 0 to 5, and we need like 100 elements here. 100 points. Okay, that's our first equation that we want to plot, and then the second equation that would be like x to the power 5 minus x plus 10. So that is like our second equation. So now we have x, we have y, and now let's just do the plotting. So plot y1, use dash red line with diamond marker with black edge color, red face color, and marker size 10 ohms. It's a lot of tests. I mean, not really, that's just simple stuff. So plot, this is our x and our y1, our first function, and it tells us use dash red line. So dash line, I mean, I just happen to know it that like for dash line you put like this 2 dash. I mean, how would you know something like this? Well, you can check your I mean, if you don't know them, you can check here like your plotting file. I put table for you, remember. So like dashed lines, that would be something like this 2 dash. Dotted dash lines, that would be a dash, and the dotted lines, that would be like semicolon. Solid lines, that would be just 1 dash. Okay, and it as like diamond markers, that would be like a D, and here are the colors. So I mean, that's how you would, if you don't remember them, that's like how you would do it. You can just check it, like so you can print this and keep it with you, or you can just check the file. Open the file and check it. Okay, now let's see what you want. Use dashed, so dash, that would be red line, so red that's R, and diamond markers that's like D. Here. The R that's the red line, and the diamond that's like D. Okay? Now that will give us the line. Now, with black edge color, so marker. So here when you write marker, it will tell you all the options that you have. So like here, like you need like marker edge color. So the marker edge color should be black. So this would be K. Remember, black color is K, blue is B, green is G, R, red is R, cyan, megan, black is the only one which is K. White is W. Okay, so black color with black edge color, red face color. So here you say like marker face color, and you put like red, and marker size, oops, you put like marker size, and it should give you 5. Okay, so something like this. So that is first task that it wants, and then like now it tells you use this. I mean, if you want to plot it to make sure that you did everything correct. Now it's telling you. Okay, it tells you, yes, we did a mistake here, because like remember when you do this power, you need to remember to put this dot, because you are not raising oops, no, you are not like treating this as a matrix and like doing matrix times 5. No, you just want to raise each point like element wise to the power of 5. So now we did this, like should be plotting something here. So okay, maybe that's like too many red dots. I mean, let's just reduce this number to maybe 20 so that it will look nice. I mean, I didn't realize it. Just 20, that should be okay. Looks much better. Okay, so now we got the with black edge color, red face color. So we have like black edge color and red face color and dash line. So we got this correct. Now plot y2. So plot here x and y2, and that should be of course, before you start plotting, it's like a good idea to add like a figure number. So I forgot to do, I mean, that's always a good practice, and to close all, like close any open file, any open plot, in case something is there, and you create a new figure with a new figure number. And then now here, let me just do this one, and then I will tell you what mistake I did here. Use solid blue line. So here that should be like solid line. Again, this is just one dash blue line, and the line width tell you like set the line width to, so here like line width, and then you set it to okay. Now if I plotted this, it will not be added to this figure. Why? Because if I want to retain what I have in this figure, then I need to use like hold on. So now like when I do hold on, that will retain whatever I have in this figure here, and then add this one to it, which is y2. So if we did this, let's just plot this one. My computer is kind of slow. Boom, boom. Yeah, very slow. Anyway, let's just do the next task until it starts plotting. So the next task is add a legend with subscript subscript for y1 and y2. So like legend. So basically you use the legend function, and then you put like y underscore 1. How do you do this? Something like this. Like how would you know like to do like subscript, superscript, or any of these things? Again, like you go here, I put this for you. So if you want to do like, for example, a superscript, then you use like this power sign, and you put it in this like curly bracket. If you want to do subscript, you do underscore and you put it in this curly bracket. Okay, that's how you do it. So that's like my first function, and then we do this for the second function. Okay. Oh, my computer is still running. Maybe I should stop it. Now it tells you like add X and Y label and title. So X label, we know how to do X labels. That's like X. These are like easy question. Y. Oops, I did a mistake here typing X label. I do like Y label. That's like f of X. And title, tell me like what is the title. Is that two functions? Okay, and then it says like grid, add a so let's just do these ones. I don't know why my computer is slow and not responding to what I need. Okay. I think that I do something correct here. Wasn't like exp. Okay. 5 is x to the power 5 minus x plus 10. Okay. Use equally this exponent of x. Okay. Yeah. So anyway, we have something that looks like this. Now I think here in the legend, let's see, I think I forgot something here, because like you see the legend now is not in a nice place. It interferes with what you are plotting. So set the legend location to the best outside. So you want the legend location to be outside and to be best. So here, like you can see like location, and then it gives you the option like north, south, east, west, northwest, whatever we want it to be outside, best outside. Okay, so that's what we want. So if we did this, like we run this again, so we got like here this legend is somewhere outside. Okay, and this is what we are plotting. Okay, so now let's see what we have here. We put like the f of x, we put the title here, add a grid and box. So like we want to, there is already a box, but we want to add a grid. So like grid would be like grid on, and box would be box on. Okay, and if we did this, that will like add a box here and add a grid here. Now set the x-axis and y-axis limit. I think here, yes, there is, I think this function, when I made this problem, let's just make, okay, let's change this problem and divide this by 1000, for example. Okay, well, that might be easier. We get some nicer plot, or not necessarily 1000. No, let's just divide it by 500. Okay, let's just divide everything by 500. Okay, 500. Let's think I just changed this problem, but I didn't change the text. Okay. Oof. Oh, okay, I see. So this one is okay. It is a problem here. So like maybe this is not to the power of 5. Let's just do this to the power of 3. Okay, that looks better. So let's just change this one to the power of 3. Okay. I mean, we just need something that plots nice. And okay, now it tells you, sets the x limit from, so x limit, that would be from -1 to 6, and the y limit from -50 to 200. Okay, and then it says at like this at x equal 2.2 and y equal 180, add the text that says beta is equal to this one. So like remember how to add text, use the text function. You put the, where do you want to put it, the x, where do you want to put it, like into y axis, and then you put the text, which is like beta is equal to something that looks like this. How can you add the Greek letter like this? Here I put like, so beta, that would be like backslash beta, and then so that would be like backslash beta is equal to y, and we remember this like 1 plus y underscore like 2. Okay, and let's just run everything now. That should be it. So yes, so now we got like, now we set our x limit from -1 to 6. We set this from -50 to 200. I mean, maybe even to make it look nicer, let's just put this like from -2 to 6. Okay, so now we have this from -2 to 6. We have this from -50 to 200, and we have whatever the beta is equal to. This is like the y1, which is exponential function, and this is the other function, the polynomial function. Okay. Now, so we are done from this problem. Let's do the next one. The next one, it's say like use line space function to create a vector that has like linearly space point from 0 to pi over 4. So like let's say our x is equal to line space from 0 to pi times 4, and I need like 101 point, something like this. Okay, so it's like my x. Create a subplot on figure and add these three functions in each subplot. Okay, so that's easy. So that's like an easy problem. So subplot, and then it needs to be like 1 by 3, so 1 by 3, and then I add my first plot. So my first one is like I want to plot x and sine of x. That's the first one, and add a title. So we can add like a title for this one. That would be like sine of x. Okay. And then I'll just do the same for the other one. So here, so that would be plot number 2, and like here this would be like cosine x, and oops, and that should be like cosine x, and that's like subplot number 3, that would be like number 3, and that would be the cosine x absolute. So I want the absolute value. So the absolute value of, again, like how to know this function, you can check like the lecture note, or you can check the cheat sheets that you have to know how to, what is the absolute function in MATLAB. Okay, so the absolute function is like APS, that's the absolute. Okay, and that would be cosine x. Okay, and here that would be, you can put like absolute of cosine x. Okay, and as a good practice, when you come here, you like make like hold off. Okay, and you can here come like figure, as a good practice, figure number 2. And then we should plot this one. If you plotted this one, then you got like your sine x, your cosine x, and your absolute cosine x, something like this. Okay, now let's do this one. So this is like use logical function to replace nan with 10. So again, like remember the logical function, you can go check the logical function you have. That would be like the one like is nan. So basically you come here, like you index d to logical index, like you say is nan d. So basically it will find all the elements that are nan in d, all the elements that are nan with d, and replace them with 10. But we first need to input d. So d is equal to 1, 2, 3, 4, then 20, then 40, 100, then 300, 400, something like this. So, and then now I make this logically check is nan. I mean, and you can do it in 2 steps if you like. You can say like index. If you prefer to do it in 2 steps, that's fine. You find like the index of the elements that are nan, and then you like the index here, like whatever this condition is true, you replace this with that. We've seen this before. So basically here I find like these are the index that are nan, and now like these indexes I'm replacing them with a value of 1, with 10, with a value of 10. So you find the 10 here, a 10 here, and the 10 here. Okay. And then it tells you multiply this with element d times e. Oops, so I forgot to give you e, so e, that would be just put e here, insert equation, because MATLAB was very slow. Oh, yeah. Slow on me. So, yeah, something is okay. So let's just matrix here. That would be like 4 times 3. Is this correct? Yes. Just 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. It tells you multiply d times e. So here that's like e is equal to this one. Okay, where e is equal, so like let's say like g, and let's say like you, this is like do this element wise. So here we make like e is equal to 4, 4, 4, 4, 4, 4, 4, 4. Okay, that's like e, and then g is equal to e times d. Okay, so if we did something like this, then we got whatever we have here. And again, you don't need to show, you just need to, you can show this one also. So basically you got something that looks like this. The final problem in this review is the round function. Remember we did the round function before, so use round function to represent in 2 significant figures. So 2 significant figures means that like 4 and 5 here, or like these 2 digits here, and everything should be 0. So let's say, so r is equal to round, and like the numbers that I want to, again, better practice is just like you can say r is equal to, just copy this here. Okay, and then like r is equal to round r, and now remember to do this to the right, you need to put like a negative here, and then you need 2 significant figure, means like I move like 1, I move 2, so that would be -2. And if you are in doubt, just keep doing it until you get it correct. So yes, so here I got like 2 significant figures. Like if you are in doubt like whether this is positive or negative, if you did it like with +2, then you will, you know, not get what you want. Then you say, okay, maybe this is -2. And if you maybe say, okay, maybe -1. So if you did -1, you get something like this. And you say, okay, so another one, then it would be -2. Okay, and then like use display function to display like r, to display on the screen r is equal to xx meter per second, replacing xx with the numeric value of r that you calculated. So basically here I want to, so there's no need to show this one. I can just say like here display, and then like open bracket, like opens this quote, r is equal to, and then plus, and then r. Is this correct? No, I need to convert this to a string, to number to string, because this is a string, so that need to be a string. So I use the function number to string to convert whatever I have here to string, and then plus, and then oops, and then I can do something here which is like meter per second. And if I did this, r is equal to whatever in 2 significant figures. So that's all for this review. Simple stuff, like easy things. If you don't know like how to use, like for example, this round function, if you are confused about dot multiplication versus like matrix multiplication or division, if you are still not comfortable with the precedence rule, you can check like your previous lecture note. Otherwise, I mean, you're good. You know, and of course, like you see here in MATLAB, there would be things that you might not necessarily know or memorize. You know, they're not fresh in your mind. You know, when you stop using like any language, you just like need to refresh it. So you can just check these things here like in a table like this if you don't remember them. That's all and for this part, and we will start MATLAB part 2.